Thank you for coming to our session on Amazon Aurora, our new relational database engine. This used to be the newest engine, but yesterday we announced MariaDB, so it's not the newest anymore, but it's Amazon's own database engine. Before I start, let me do a show of hands so that I know how to pace through this presentation. How many of you have used Aurora? Can you raise your hand, please? All right, not that many. How many of you have been to another session on Aurora, either in this reInvent or previous Amazon events like AWS Summits? OK. All right, thank you. So let me start with the basics. So what is Amazon Aurora? It's a MySQL-compatible relational database that has the performance and availability of commercial databases, but the simplicity and cost-effectiveness of open-source databases like MySQL and Postgres. And it's delivered all as a managed service on Amazon RDS, Relational Database Service. Now, before I get into all the technical details, let me start with a couple of customer stories, and then we'll talk about performance and availability and other stuff. So customers are using Aurora. And you might have heard about this in Andy's keynote yesterday. We did our launch in end of July, and after 2.5 months, Amazon Aurora is the fastest growing service in the AWS history. Now, AWS itself is not that slow moving, so you can imagine the fastest growing service within AWS is actually means something. So we have a lot of customers. Some of them are on the screen here. These are the ones I can talk about. There are many more I can talk about yet, including, so the ones that we have, Expedia actually is here, and they are going to be speaking in the session after this, which is on enterprise workload on Aurora. We also have GE Oil and Gas, PG&E, and many others. Now, a couple of quick things about what these customers are doing. As you know, Expedia, many of you are very familiar with, especially in the US and other places. They are an online travel company with portfolio including 150 travel sites in 70 countries, right? So they needed a relational database for their analytics and real-time business intelligence for their travel marketplace data. And they are currently on SQL Server, and which was getting too expensive because the data volume is growing. And with increasing data volume, the performance actually doesn't do very well. Right? So they're looking for something different. They tried Cassandra and Solar Index, and you're going to hear more about that if you go to the next session. And they came to Aurora, and they are one of the first customers who started running their production application on Aurora. In fact, they wanted to do that even before we went GA. We stopped them. And what Aurora gives them is the scale and performance at an affordable cost. Right? What they do specifically in their current application is 25,000 inserts per second, with a peak of 70,000 inserts per second, with 30 millisecond average response time for writes and 17 milliseconds for reads. Pretty impressive numbers at that scale. PG&E, another good example of an Aurora early adopter. And as you know, this is one of the largest utility companies in the US. This is the utility company for the northern central California. They have 16 million customers covering about 70,000 square miles. And what they wanted to have is a database which will be very, very reliable and which can scale very rapidly when they have high traffic surge during the power events, right? When everybody wants to go to the website and figure out what's going on, if they have power. Well, I mean, they can do that from cell phone today. So, and what they found interesting in Aurora is the 6-way replication that we do in our storage layer. So every piece of data is replicated across 3 different availability zones or 3 different data centers, and across 6 different storage nodes. They found that really, really interesting. That will give them the resiliency that they're looking for. Other thing that they found very, very interesting is the number of read replicas that we have. With Aurora, we can support up to 15 read replicas, which you can spin up very, very quickly, because they all read off the same shared storage volume. So you don't have to restart your replicas from scratch. And especially during a power event, when they want to spin up these replicas quickly, that works very well for them. Another customer example, ISCS, probably not as well known a name, but they are actually very, very popular company in the insurance space. They do policy management, claim, billing and solution for property insurance and other things. And they have been an Oracle and SQL server shop for a long time. And the cost and maintenance of traditional commercial database that they are struggling with. They are probably not the only one. A lot of other people struggle through the same thing. So what they saw in Aurora is our continuous backup into S3, which eliminated the need to have a backup window, and a lot of, for example, DBAs spending their hours on taking backup and then having to recover from that if they have to. They also like the read replicas and continuous upstream of data or uploading of data from the read replicas into Redshift. That's another AWS service that they use. And they could do all of these with 70% less cost than their SQL Server deployment. Pretty impressive savings for what they are trying to do. Alfresco, this is another one of our customers. In fact, John Newton from Alfresco, I think, just gave a talk the session before this. They are an enterprise content management company. They have 1,800 customers in 195 countries, including leaders in financial services, healthcare, and public sector. And they wanted to build a document repository on the cloud, which will scale to billions of documents. And they did that with Aurora. In fact, they scaled to 1 billion documents with a throughput of 3 million documents per hour, which is 10 times faster than their current environment in MySQL. So they are moving their SaaS application to AWS and Aurora. And John just talked about that in his session. Arth Networks, another interesting example. They are a weather management company. They have weather sensors in 10,000 neighborhood level, 10,000 neighborhoods, and they deliver very precise reports on weather condition and local forecast, right? And they process, as you can imagine, for weather forecasting, 25 terabytes of real-time data, and they needed a database that can scale up to that requirement. So they are, again, another customer who moved to Aurora from SQL Server, and this was an easy move, which was pleasantly surprising, and a huge cost savings for them. My last example, not the least, is ThreatStack. This is another very interesting customer who provides AWS customers with continuous security monitoring to protect against intrusion, data loss, and insider threats. Again, a very write-heavy application. They are ingesting close to about 500,000 data items per second, and they ingest about 10 terabytes of raw data per day. They tried various different things, including NoSQL solution, and they are running on Aurora. So before I talk about performance and availability and other things, I wanted to set a little bit of a context. Why did we start working on Aurora? Did we really need to build another relational databases? There are plenty of them, right? In fact, there are very popular ones, both commercial and open source ones. And it's a mature field. People have been working on databases for 40 years. So is it possible to still innovate in that space and differentiate yourself in the market, right? So we started working on this about 3.5, 4 years back. And we soon realized that traditional relational databases are not designed for the cloud. Well, they were actually designed for mainframes by people in IBM for whom it was actually a very good design. It's multiple layers of functionality, all in a monolithic stack, which is good to run in a single box, which is what mainframe was. And over the last 30 years, not much has really changed, right? Well, we have made it a little bit scale out. So people have added sharding. You have added clustering. There are different types of clustering. You have shared nothing clustered, shared disk clusters. But fundamentally, if you look at the stack, it is still a monolithic stack, and not much really has changed. And this is not really what we would like to do if we had to redesign. If we have to redesign the database for the cloud. I mean, this is something which is not good for cost, not good for flexibility, it's not good for availability in a cloud environment, which is fundamentally scale out and multi-tenant. So we started from scratch. We cleaned our tables and started thinking that if we have to design the database today, are we going to design the same way people did that in 1970s, right, for the mainframe that they did it for? Probably not. And today, if you have to start from the scratch, you'll build something that can scale out, that is self-healing, that leverages the cloud services that you already have, so that you don't have to reinvent the wheel every time you need a new component. And that's what we did with Aurora. It's a service-oriented architecture applied to databases. I'll give you a couple of examples. And there are, of course, many other things that we have done in Aurora which is not captured here. One of the things that we did is that we took the monolithic stack that he talked about, and we looked at every layer and thought about how we can make it more cloud-friendly. So we started with the logging layer and the storage layer. We put them together into a single log structured storage, which is scale-out, multi-tenant, and purpose-built for databases. Right? That is probably the most fundamental innovation in Aurora. We also used a lot of AWS services, like EC2, like VPC, DynamoDB, Simple Workflow, Route 53, et cetera, in order to build various different services that we use in Aurora, especially on the control plane. We integrated Aurora with S3. What it allows us to do is to take continuous backup into S3, so you don't have to worry about backup or having a backup window or recovering from backup. This is all automated, and I'm going to talk about it in the presentation. So let's talk about performance. Aurora is fast. In fact, this is from Alfresco, and John Newton saying, we ran Alfresco workload on Aurora. We were blown away to find that Aurora was 10x faster than MySQL environment. And no, we didn't pay him to say that. And he's actually here. He's actually so excited about it. He wanted to give a talk, and he presented in a session just before this one talking about what they're doing with Aurora in their enterprise content management space. So how fast is Aurora? So we did different benchmarking. And this is the benchmark result we can publish. This is using MySQL sysbench. And this was on an R3-8XL machine, which has 32 cores and 244 GB of RAM. Our write performance was 107,000 IOPS per second, and our read performance was close to about 600,000 IOPS per second. Pretty impressive number. You will ask that, how does that compare with MySQL, for example? It's 5x that of MySQL, both in terms of reads and write performance. Now, anyone can generate a suitable workload to show a good benchmark result. So we looked at how we scale, right? So if we, for example, increase the number of tables from 10 to 100 to 1,000 to 10,000, can Aurora really stand up? And we did very well. If you look at Aurora performance, at 10,000 tables, we had 60,000 IOPS. This is write IOPS, by the way. And when you go to 10,000, it's 54,000. So it scales up pretty well, or holds up pretty well as we scale the number of tables, size of the database. If you compare this with MySQL on i2-8XL, which is actually a more powerful instance than R3's, and if you scale up to 10,000 tables, the performance goes down significantly. In fact, if you look at the headline numbers, we are up to 11x faster than what you can do on MySQL and similar or better hardware. What about number of user connections, right? We have a lot of applications with a lot of concurrent user threads. And we scale the user connections from 50 to 500 to 5,000. And again, if you see Amazon Aurora, it goes up, actually, the number of OLTP writes or OLTP transactions per second from 40,000 to 71,000 to 110,000. It actually scales very well with number of connections. In fact, one of the things, if you want to take away from this, if you have an application which is very, very concurrent, or if you can write an application which is very, very concurrent, Aurora does very well. And comparable number for MySQL, with 50 connections is 10,000 IOPS. Then with 5,000 or 500 connection, it goes up to 21,000. But then when you grow beyond that, it actually goes down. And at 5,000 connections on an 8XL machine, you get only 13,000 transactions per second. So it's roughly about 8x faster, up to 8x faster than what you see in MySQL. So how do you do this, right? Very simply, doing less work and being more efficient. And I'm not going to get into all the details of how we do this. There was another session yesterday. You can, if you haven't attended that, you can take a look at the video stream where you went into the great deal of details about how Aurora achieves the performance numbers and how we are available. But I'll give you one example. The total number of I/O that we generate and comparing that versus MySQL. If you look at the MySQL architecture on the left, we do a lot of I/O when we are doing writes. We do log writes, we do bin log writes, we write data, we write into double write buffers, and many other things like that. One thing we have done in Aurora, and I kind of went through that a little quickly, is that we have a log structured storage system which is purpose-built for the databases. This is not a standard storage system with iSCSI or NFS or things like that. So only thing we write to the storage is really the redo log records. We are not writing anything else, right? So consequently, the amount of I/O traffic that we generate from the instance into the storage is an order of magnitude or orders of magnitude lower than what you see in MySQL. So how much lower it is? We actually took a 100 GB database and ran 1 million sysbench transactions with read-only, write-only, and OLTP, and read-write, different types of transactions. And you can see the amount of I/O traffic that we generate at the instance at MySQL and Aurora. Aurora is 1/50th of what you need to do on MySQL. That's one of the reasons we get high performance. There are many other things that we have done. For example, we have rewritten a lot of the code with lock-free implementations. We have done a lot of asynchronous processing. So all of these contribute to tremendous amount of performance gains. Aurora is also highly available. And you can see some of the customer codes what they are talking about Aurora's availability. So the primary reason, or there are many reasons, of course, but I'll take you through a couple of the highlights. So Aurora's storage architecture is very unique. What we do is that for every piece of data, we actually write 6 copies of it to 6 different storage nodes in 3 different availability zones or data center. So in every data center, we'll have 2 copies of every piece of data, right? That is kind of the foundation on which the Aurora availability is built. And we do quorum-based read and write. So for example, when we write into this 6-node environment, we do a 4 out of 6 quorums. As soon as we get response back from 4 nodes that the write is stable, then we consider that writes to be stable. For read, we do 3 out of 6 quorums. We also do background scrubbing of the storage node, CRC on the where on the disk. And within the storage cluster, there is peer-to-peer replication that goes on. So for example, if one of the storage node is behind, then the peer-to-peer replication helps catch it up. We do continuous backup into S3, and we are also doing background hotspot management. So a couple of other interesting things about Aurora is our crash recovery approach. If you're familiar with MySQL or other databases for that matter, what people typically do is that you checkpoint every 5 minutes or so, and then after you recover from a crash, whatever log records you have in store, you replay that, and typically that happens in a single-threaded way, at least in MySQL, and that takes a while, sometimes minutes, sometimes more than minutes. Now, in Aurora, it is actually very, very different. Our storage node have all the logs, so we are not applying it at the instance. In the storage node, we store all the logs, and when you recover from crash, we apply those logs on demand and asynchronously. So you don't have to really wait for all the log replay to happen. You pretty much recover from the crash instantaneously. Another interesting thing we have done in Aurora is that we have taken the cache out of the database process, right? So what does it help with? So if you, for example, have to restart the database after a deadlock or whatever other events you might have, the cache remains warm, and you can start much quicker. And if you are trying to resume from a fully loaded operation, you can resume much, much faster. And the combination of instant crash recovery and survivable cache gives us quick failover and crash recovery that we have done some measurements. And let me walk through this a little bit slowly. So if you look at what happens after a failure, so database fails. That's on the left-hand side on the top picture with MySQL. There is some time which is spent on failure detection. And after that, the recovery starts. In case of MySQL, the recovery is kind of unpredictable. The time it will take is unpredictable because it depends on crash recovery, which, again, is depends on how much of log replay you have to do and other things. In parallel, there is DNS propagation that is happening. That is, your primary is now switched over to a different node. The new IP address needs to propagate to the network, so the applications know which new primary they need to connect to. And after that, the app can start running. Now, in case of Aurora, our failure detection is not very different from what we do in MySQL. Now, it can be faster. In fact, we are working on something where the failure detection will be faster. So instead of 15 seconds, you can probably do that in less than 5 seconds. But the recovery is very, very short and predictable. And the DNS propagation, something you can eliminate if you use, for example, a special connection driver that we have, where instead of relying on the DNS, it queries a table in the database and finds out who the new master is, so you can eliminate the DNS propagation time. And if you use that driver, the Aurora failure recovery can be less than 30 seconds. In fact, we hope to bring it down to less than 10 seconds with faster failure detection. Now, you can test all of this yourself. There are SQL commands that we have that you can try and simulate this and see how fast Aurora recovers. So going to the next part, it's not only reliable and highly performing, it is also important to make the databases easy to use. And we have spent actually a lot of time making it easy to use. And there are a couple of aspects to it. The first one is that Aurora runs on the RDS platform. Now, I don't know if you are familiar with the RDS platform. It's a managed database platform where a lot of the things that we need to do in managing a database is actually taken care of by RDS platform. And you can focus on what you want to focus on, which is schema design, query construction, query optimization, writing your app, and things like routine maintenance, advanced monitoring, patching, push button scaling, both in terms of instance size and the storage, et cetera, security and compliance, backup and recovery, automatic failover, that's all taken care of by RDS platform. We have also made storage management very, very simple, right? In typical databases, even with other engines in RDS, people are very worried about running out of storage. So they typically over-provision. And I have seen people over-provision anywhere from 30% to 3 times. In Aurora, you don't need to do that, right? When you start your database, you start with a single 10 gig segment, 10 gigabyte segment. And as you run out of space or come close to that, we automatically add more segments to it. And you can grow all the way up to 64 terabyte, which is 10 times or more than 10 times what we support in other engines in RDS, right? In addition to that, we are also doing continuous backup into S3. So what we do is that, as I said, this is a log structured storage system. We stream those logs into S3, and when you have to recover from, or you have to restore from a backup, we stream those logs back into our storage system, and we can reconstruct the state of the storage to a point-in-time recovery that you want to have. You can do instant snapshot. There is no performance impact. Again, because of the log structure storage, all you need to do is to essentially save the pointer where you want to take the snapshot. We do automatic restriping. We do repairs, hotspot management, and also encryption, which is coming soon. We have also simplified some of the common data security requirement. Now, the encryption is not there yet. It's going to be available in the next few weeks or so. And the key management is integrated with KMS, so it's kind of easy to manage. We have SSL to secure data in transit. Amazon Aurora, by default, actually resides within VPC, so you get that VPC security for free or all the access management for free. And there are industry standard security compliance that AWS and RDS have gone through that you also get. We don't have FedRAMP or HIPAA compliance yet, but that's going to come soon. So now, an important part of running a database or any enterprise stack is monitoring. And we have CloudWatch metrics-based monitoring that is available with Aurora. And we monitor CPU utilization, storage, memory, many other systems and OS-level metrics. But we are working on something which is actually a lot more interesting, again, something which is we're hoping to make available in another few weeks. So we will support a lot more metrics. This is something that we got requests from a lot of customers, is that they would like to see what we see, right? So we have 50+ systems and OS-level metrics that's going to be available through an advanced monitoring system. And we'll also have things like, for example, process lists, something that you get from top. We'll have very fine granularity, and you can control the granularity based on how much of debugging you want to do, anywhere between 1 to 60-second granularity. And you can consume this on RDS console, right? So if you have an Aurora instance, you can create your own dashboard with all the metrics that you want to observe, right? It doesn't have to be all 50. You can be a subset of that. You can customize your dashboard where something you want to expand and you want to have a bigger screen area for that. In some cases, you don't want to have, for example, the graph. You want to see a simple CPU utilization number. You can set, for example, alarms, and you can monitor those alarms. And more interestingly, you can also move this into CloudWatch. You can stream this data, which is available as a JSON file, into CloudWatch, and then using an API, connect that to third-party monitoring tools like Graphite, Ganglia, AppDynamics, whatever have you. So if you have, for example, an end-to-end application stack that you want to monitor, which has app servers, web servers, database servers, and your database server is running in RDS, your app server is running in EC2, maybe something else is running on-prem, you can collect all of this monitoring feed into a single dashboard, and you can do an end-to-end monitoring. Other thing we have worked very hard on is to make migration very, very simple. So if you're already on RDS and running MySQL, it's a couple of clicks, right? All you need to do is to establish a baseline, which is taking a MySQL snapshot or just selecting a MySQL database that you want to migrate from. And with a couple of clicks, you can migrate that snapshot and create an Aurora instance as a baseline. You can then run a binlog replication, or you can use your Tungsten replicator to do the catch up. And when you catch up, you can do a cut over to the new Aurora instance without or very little downtime. If you are not in RDS, or if you're not in RDS MySQL, we just announced our AWS database migration service. So if you are using, for example, Oracle or SQL Server, or coming from outside of RDS or on-prem, you can use the AWS migration tool to migrate into Aurora. It's also quite simple. And We also support a schema conversion tool. So if you're coming from Oracle and SQL Server, you can use the schema conversion tool to help you. Now, one thing we paid a lot of attention to is to keep Aurora MySQL compatible. And the advantage of doing that, the rich ecosystem we have for MySQL, both in terms of all the ISVs, all the tools, and all the applications people have written, those can very easily transfer to Aurora. So for example, on the business intelligence side, Tableau, Zoom Data, Looker, all of these common tools and ISV applications work with Aurora. For data integration, things like Talent, Attenuity, Informatica, these are all certified and tested on Aurora. For various different query and monitoring tools like Webyorg, Toad, Navicat, all of these work without any issues on Aurora. And we have a number of system integrators and consulting partners who are helping customers migrate from other databases to Aurora. So some of those are listed here. They're also available on our website. So this is all good technical stuff, but does Aurora save you money, right? And I'll tell you, and this is part of the presentation in the next session we have, if you are coming from an enterprise or commercial database, you will save obscene amount of money coming to Aurora because there is no licensing fee. But what is surprising that even if you are using, for example, MySQL, you can still save money. And I wanted to take you through that in a little bit of detail. So this is our pricing, again, available openly on our website like any other AWS service. And if you look at R3 Large, that is the smallest instance that we provide, it's an hourly price of 29 cents. And then if you go all the way up to 8X Large, it's $4.64. It's simple pricing. There is no licensing like your commercial databases. There is no lock-in. You pay only for what you use. And if you use reserved instances, you get pretty good discount, 44%, up to 44% with 1-year RI, and 63% with 3-year reserved instances. So let's, sorry, maybe I should talk a little bit about that. And the storage also is built on a consumption basis. You can grow up to 64 terabyte of storage, as I mentioned. It's 10 cents a gig per month. IOs are also built on a consumption basis. There is no provision IOP that you have to pay for. It's 20 cents per million IO consumed. All prices here are for Virginia, by the way. So how do you save money in your cost of ownership versus MySQL? So this is kind of a simple example where you have a MySQL configuration, pretty common configuration, actually, that we have in RDS. You have a primary instance on the top left-hand corner there, which is with an R38XL. Then you have a storage attached to it, which is 6 terabyte, 10K IOPS, or PIOPS, provision IOPS. And then you have standbys, R38XL with 6 terabyte and 10K IOPS, PIOPS. And the standby, as you know in RDS, it's an idle standby. You cannot really use it as a read replica, right? It's used only when you fail over to the standby. And then you have, let's say, 2 read replicas. Again, R38XLs, 6 terabyte of storage, and I have used 5K PIOPS because you don't need for read replicas that much of provision IOPS. If you add up all the cost here, it kind of comes down to instance cost of $15, 12 cents per hour, and storage cost of $8.30 an hour, okay? So you add all of this up, it's $23.42 per hour for this configuration. So let's look at an equivalent configuration with Aurora. So your configuration will look like this. Again, because we use a shared storage environment, you don't need 4 storage volumes. A common 6 terabyte storage volume is all that you need, right? So everyone reads from the same shared storage volume. You have a primary, which again is R38XL. You don't really need a standby, because in Aurora, the read replicas are promotable to master when something bad happens, right? So you can get rid of the standby. And you have two read replicas, R38XL again, and they're at $4.64 an hour. So if you add all of this up, it's $18.35, and which is about 21% of savings over MySQL, which is probably the cheapest database that you can use. But you can save even more. How do you do that? So we talked about Aurora's performance gains, right? Aurora is, for many applications, of course, your mileage will vary depending on your workload. But for most applications, getting a 2x performance improvement is not a problem. You'll see that pretty commonly. I cannot guarantee that, but it's pretty common. And if you have a 2x performance gain, you can easily scale down your 8XL to a 4XL. And with a 4XL, the price of this configuration comes down to $11.39, which is 51% savings over the MySQL configuration. Okay? Now, don't come back to me and say that I'm not getting 50% for every configuration you have. But this is an example where you can, or this is kind of savings that you can get. Now, you're pretty much at the end of the presentation. Please remember to complete your evaluation. I'll be happy to take some questions.